Hello. In this video, I'll be demonstrating my Kafka-based order processing system. I'm Ken Purnima. My registration number is EG20204115. This system is implemented using Python, Oro serialization, and a Dockerized Kafka environment. The objective of this project is to build a complete data processing pipeline that supports real-time message streaming, structured data using Oro, retry logic for temporary failures, a dead letter queue for unprocessable messages, and seamless deployment through Docker. Now, let me walk you through each component and its purpose. Here's my project structure. The Docker Compose YAML file to run Kafka and Zookeeper, the Oro schema that defines the structure of each message, the Python producer that sends messages, the consumer that processes messages with retry logic, and the DLQ consumer which handles permanently failed messages. Seeing the folder layout first gives a clear overview of how the system is organized. This is my Oro schema used for every order message. Its purpose is to enforce a consistent message structure across the system. The schema defines three fields: order ID, product, and price. Using Oro ensures that every producer and consumer agrees on the same data format, which prevents schema and mismatches and parsing errors. This is my Docker Compose file. Its purpose is to create an isolated and reproducible environment containing both Kafka and Zookeeper. Kafka is exposed on port 9092, so my Python applications running on the host can connect to it, and advertised listener is set to localhost to make communication seamless. Once this setup is complete, I can launch Kafka reliably using a single command. Now, I'll start Kafka by running docker compose up-d. This brings all services online in the background. I then run docker ps to verify the Kafka and Zookeeper are running correctly. This setup confirms that infrastructure is up before I run any producers or consumers. Next, I enter the Kafka container and create the topics used by the system. The orders topic holds normal messages, and the orders DLQ topic is reserved for messages that fail even after retries. Listing the topics confirms that the Kafka environment is now ready for message flow. This is my Python producer. Its job is to generate order messages, serialize them with Oro, and publish them to the Kafka orders topic. The producer simulates real-world order data by generating random product names and prices. The Oro serialization step ensures that the data is compact, fast, and conforms to the schema. I will run now the main consumer. This component listens to the orders topic and processes incoming messages in real time. Its responsibilities include deserialization of raw data, printing the order details, updating a running average of prices, and handling failures using retry logic. When a message triggers a failure, the consumer automatically retries it 3 times before giving up. In a separate terminal, I now run the producer. You can immediately see that as the producer publishes messages, the consumer processes them live. This demonstrates the end-to-end data pipeline functioning correctly. Finally, this is DLQ Consumer. Its purpose is to capture and display messages that failed after all retry attempts. This ensures that no data is lost and allows failed messages to be inspected later. The DLQ is a critical feature for building fault-tolerant production-grade systems. To finish the demo, I'll stop all running services using Docker Compose down. This ensures a clean shutdown of Kafka and Suki. To summarize, this project demonstrates a complete Kafka-based streaming pipeline that meets all assignment requirements. Real-time data processing, strongly typed messages using Auro, robust retry handling, a fully functional dead letter queue, clean deployment using Docker. The system reflects a scalable and fault-tolerant architecture commonly used in real-world big data pipelines. Thank you for watching.